We're just giving everyone in East Idaho a few minutes to get logged on.
Is this Thunder Thursday? Oh, they got us muted, huh?
Travis told me he doesn't like us.
Apparently, since he just doesn't listen to any of us. You're not used to it.
My cheeks, and those are reliabilities, man.
Hey, Shane.
Live audio.
What's up, dude? Sorry, we're running a couple of minutes behind. Dylan got stuck on a call, and then I made him take me to the drive-through at Taco Bell before we left town.
Are you driving or is Dylan driving?
Dylan's driving.
That put us on.
We're all here.
Hey, guys.
Hey,
What's up, Laren?
not much. Just running late, grabbing pizza.
What
Who
kind
all's
of pizza
there?
did you get?
Dom, yeah, Little Caesars.
What?
Yeah, Little Caesars. Are you guys on the
Did you get Andrew?
I already have one. I'm just keeping up the
Who all's there, Larry?
Hey,
We're almost there.
okay. We've got Anthony, Andrew, and me, and Dylan and Shane are, of course, are on their way.
Okay, cool.
And we should be probably, I don't know, Brody's coming. Matt's going to be a little late. Get screwdriver.
It ain't got no gas.
Can't get no gas. You're right. It's all broken. It's got no gas. You want to put us on speaker? Or put noodles or whatever.
You guys there?
We're all really considering future Anakin Skywalker.
Shane, say something to me.
Simmons. Hi, Dustin. Put your camera on.
Hi.
What? You want me to sing you a song?
Yeah, do it, Shane. Sing.
See how long they know that.
Oh, I did that was.
Doesn't she do? Oh, wait, that song? Oh, God. I was thinking more like the Titanic song.
No. There's the cat, literally, your chain.
No, that's Canada's phrase. Celine Dion.
Okay, I guess we're gonna get started. Let's see the one. Okay, so we're gonna go over like control circuits, some electrical diagnosing, just some like basic electrical stuff. So for today, we're gonna like focus on like a walk-in freezer. Feels weird being up here in front of everyone. So I just wanted to start by kind of going around the room and giving everyone a chance to name something in like a walk-in freezer circuit that we deal with, diagnose. So Cody says T-stat, so we got a T-stat.
Solenoid coil.
Jalen says solenoid coil.
Contactor.
Kind of contactor.
Contactor.
Okay, Colin, defrost contactor.
Disconnect.
Fan contact. We can put a disconnect. I mean, usually there's a disconnect unless you're some sketchy place. Joel, what about you? Your evaporator motors. Joel says evaporator motors. Condenser. John says condenser motor. Condenser skid, man. Shane.
Did you say Shane?
Yeah.
Headmaster?
Well, electrical controls.
Oh, electrical. Sorry, I can't hear you. Clicks on.
Okay, we can put that on there. Clicks on. Like defrost termination fan delay.
Yep.
Defrost heaters.
Evaporator pressure regulation.
We're forgetting like.
Cody said defrost heaters.
No?
Controls.
What did Idaho Falls say?
Andrew said the EPR,
Electrical controls.
electrical controls. That's
Just think of like your standard like walk-in freezer when you walk into
Single system.
Wyatt's Taco Shop. Okay,
we
Cody,
already said defrost clock.
time clock.
What's Anthony got?
They're talking to you.
I didn't hear what's been said.
What electrical things? Just name one.
Defrost clock?
Yeah, you said that.
Roll?
Low pressure control. He's a low pressure control.
Okay, we got pressure controls. Contactors, chain cycle control. I got like fan delay, defrost turn, disconnect, condenser motor, evaporator motor, defrost heaters, solenoid, T-stat, pressure controls. Travis has compressor.
I tried to mold condensers.
Anyone think, are we missing anything?
How about a fan cycle control?
Okay,
This is not our conversation, right?
anyone think of anything else at all?
Start capacitor.
Yeah, we could throw, I mean, that on there, you definitely counter that. Capacitor, start components.
Do we put contactors?
Yeah, I said contactors in the beginning, but they're like, which ones?
Oh, or that should have been a contactor.
There's that.
We'll throw on compressor contactor. So that's like a pretty good list, I think. And then, so this is kind of like the normal things we encounter. Just so everyone can hear, in case people didn't hear to begin with, we have a T-stat, solenoid coil, defrost contactor, disconnect, evap motor, condenser motor, clicks on, defrost termination, fan delay, defrost heaters, time clock, pressure controls, compressor, fan cycle, capacitors and start components, and a compressor contactor. I feel like that's a pretty good list to start with, right? So how do you guys all feel like you do like electrically? Like, do you guys feel like you guys are pretty good with electrical? Yeah. So I was kind of thinking like,
Schematic.
we've all like worked on stuff that like doesn't have a schematic, stuff that wire mess everywhere kind of thing. And there's been like a few times that like it's been such a mess that I just decided to start over. So today we're kind of gonna do that. We're gonna just kind of like start over. So I was hoping that, I don't know if you guys can write this down in Idaho Falls, but if you guys want to, you can grab a sheet of paper and you can write down these components so that you remember them, or you can just look up here.
We'll look up.
We're gonna use the thermostat. You guys write that down, Larry?
You're
Yeah,
muted.
Okay, we're gonna do a solenoid coil.
Okay.
We're gonna do a defrost contactor with the defrost heaters. We're gonna do an evaporator motor. We're gonna do a compressor / condenser motor, like a condensing unit. We're gonna do a time clock. We're gonna do our pressure controls, a fan cycle, and a compressor contactor. So I was just gonna give everyone a few minutes to basically draw a wiring diagram of what you think this circuit should look like with these components in it. And then we'll go over it together.
One second. We're gonna grab pens.
Want the disconnect on there too?
You guys can, I didn't draw it on the upstairs, but Wyatt's taco shop is old and they ripped out the disconnect, so.
Sounds about right.
And well, I mean, obviously we'll use a 120 volt circuit and then we'll kind of go over, like when we go to the shop, like 120, 208, stuff like that. So.
So Lauren, do you have all your guys with paper and pen and drawing up their own wiring schematic right now?
So Anthony and Andrew both have a paper and a pen. Yes.
That's who you got at the shop?
So far, yeah, and I've got Dylan and Shane coming, but They're in transit. I don't think they should be driving.
We're coming down. We'll be there in like a minute.
Cool.
Here and I'll, does everyone have these written down so I can delete them for a second?
No.
Okay.
I'll take a picture. Yeah, that's.
So write down temperature control, solenoid, defrost contactor, evaporator motor, condensing motor and compressor together.
It's like, just like one, yeah.
So it's one.
You can put just a compressor, that's fine.
Defrost heaters, time clock, pressure control, fan cycle, and compressor contactor.
And just to give you guys a few hints, like, there are a few items on this that are not gonna be on your control circuit, right? So think about that, like, some of these items are control, some of these items are loads, etc. Some of them are line voltage, some are control voltage.
I
So
can
just,
throw that in the chat.
just because we, you know, these are the list of components we're gonna look at downstairs. And then we're kind of gonna go over. John helped me and Larry and Matt work together to make a little trainer to go over all these. But just keep in mind on your diagram, you're looking at a diagram, a lot of times you're looking at the control circuit, right? And you also have like a diagram usually off to the side that's like your line voltage circuit, so. Primarily the focus here is to draw the control circuit. You got all those, Travis?
Yeah, I sent it to them all.
And I'll give you guys one more hint, I'll draw the first part of it for you. There you go.
Way off.
And if you guys don't know, like, there's no, you know, there's no shame in that, like, that's what we're doing this is, so hopefully. By the time we're done to here. And I'm sure the one like we draw together is probably not like what the manufacturer would look like, it's just. You know, there's multiple ways you can draw it, so.
I'll go email my estimates I did for that thing real quick.
Never mind.
I was gonna email those estimates over because they want them by day to day. But it's all right, I'll do it.
It made me nervous, like standing up here, my hands are like shaking a little bit, or maybe it's just like caffeine rush, I don't know.
Do you want your L1 and L2 that far apart?
Maybe, I don't know. It's hard to judge, like drawing on a big old whiteboard.
Can you draw, did we have someone on that? Yeah, we did.
Yeah.
Can you draw, like, the, diagram drawing of what it would be, like on solenoid or thermostat or,
Like just down here,
yeah, just side, off to the side.
okay, so. Who knows what that symbol is on a wiring diagram? Okay, Lance?
Oh, good. No, you are sorry, go ahead, it's a pressure.
Temperature. Can you guys, I don't know if the Idaho Falls guys can see that, but,
What I could do is I could actually join with my phone.
We can't.
Hold on, I'll get there.
open on rise, goes in the fall. Yeah, so then the other way around would be like this, right?
Helping me back tonight.
And on the diagram, like I did downstairs, I don't even think I paid attention to that part of it, but, if your key staff, that's the symbol you would use on your
So-
wiring diagram.
Can you guys see if I've got my phone live?
Board up there as well.
Say what?
You have a control board.
Laren, can you see my phone picture or no?
I cannot.
Here you have.
Let's see if we can figure that work on this.
Yeah.
Way we'll probably try to transfer to his laptop in a minute once he gets here.
So,
Oh, there we are. All right, Travis, I see you now.
okay, so I can stand up here. Also,
What about that control? Why, do you know what that symbol is on a wiring diagram? Yes.
Basically, that's the thermostat and then the walk with the box against the power.
does that help, Laren?
Thanks, Travis.
Okay,
What about these two symbols?
let's see if somebody.
Hey, Larry, does anyone over there want to try to guess what this symbol on a wiring diagram would be?
Yeah, 1 second. Let me see if we got, before we move screens real fast, go from Travis to you.
Hey, Dustin, can we see the legend?
The legend?
I do not see your board there, Dustin. It looks like white from here.
Oh. I wonder why they can't see it.
If you click on my phone screen, it should make that one your bigger screen.
Okay, let's see here. Oh, we're seeing pictures. Oh, those are the pictures from Travis that are taken. Okay. Look on the chat. Go to.
Yeah, but you should be able to see my phone camera.
Okay. Fine. Yeah, I see. Is Dustin on the right side? That's on your camera. I don't. It's a pepperoni. Who's okay? Once you. Oh. Yeah.
Okay,
They cut this.
this symbol.
We're 1 second. I think Matt's here. I'll go grab his laptop.
Okay, what if I?
So this is a normal published switch. So obviously that one.
Is that for just power supply or power?
Depends. Actually, I've seen them both ways. Usually they're supposed to be in de-energized still.
Nope, that's not Matt. That's on his way.
That's what it looked.
I've seen them do a both.
They'll note it on the schematics if it's in the energized state, which is never that way. Almost. It's always gonna be, if there's no power applied to it, that's how it sits.
Just for example, look at this. Sometimes you see that. Sometimes you just see that.
Read it, can't wire.
I don't see that very often.
Just something like that. What would you guys think?
They're a motor.
A motor, a light, a load, right? You have L1 on the left, L2 on the right. Usually like with this, like here's our pressure switch. Usually you have, this goes to your pressure switch or your temperature,
It's all in.
and then to your pressure switch, right? And then this goes to your load, and this goes back to L2, right? So if this was L2, And this was L1.
That's Matt.
Here it's L1 too, right? So right here it's what? L1 or L2?
That's low one.
And right here. Here. So usually when you have like these switches, it's all one side of the power. It's all L1 going through the switches.
Because that's all your safeties for that compressor.
Your load is fine in outlet, right, or whatever for your vacuum cleaner. You have your hot, your neutral. In this scenario, all this is L1. All this is your hot leg, and then your neutral is the other side of the load. Does that make sense?
Yeah. What's up with these?
Well, we got our T-stat, pressure control, normally closed switch, normally open switch, and load.
Yeah, dude. Because you don't have the deep drop. Timer.
Is everyone done with their wiring diagram?
Somewhat.
They ask questions there.
So who wants to be brave and put like the first part of the wiring diagram on here? Or of all those components we listed, like what do you guys think would be first?
Cooling demand, thermostat.
Okay, what about before the thermostat?
Oh,
Time clock? Okay. So where would you put that? No, like where you wire up to this? We'll make it easy and kind of just do it based off of what we're gonna see downstairs. You know, just to kind of visualize, so it's not gonna be like a manufacturer's diagram per se. Well, let's just put our time clock right here, right? So then on our time clock, we don't have to use numbers or anything.
The solenoid or the T-stat,
Hold on,
so it should go up. So as the heat rises, it closes.
yeah,
I messed up.
That fan without a heater.
Hey, Matt.
Mm.
You got your computer? Okay.
Not all the time. One leg is, but then the other leg's still to the quick on.
okay, so here's our time clock, right?
Temperature hotter.
Set time clock. Hook our time clock to our power, so you power up your time clock.
You want to snap a picture of that? And I'll throw it in the chat.
Now I know what he's talking about. Getting sweaty already.
Say what? So Jaylen's gonna power up our time clock. Yeah. Well, you got 4 terminals on this time clock.
Oh, yeah.
So which terminal are you gonna power, are you gonna run L1 to?
Well, this one, and then.
What do you guys think? Here is the bottom. Because this is your timer, right? Timer is a motor in the time clock. So it's gonna be a load, right? So you have your L1 comes down here to your time. Okay. So where's your L2 go?
Anybody from Eastern Idaho wanna shout out where L2 would go on the time clock to help Jaylen? You're muted.
It's hard to see. Matt's trying to pull it up on his computer.
But you got an open or a closed switch?
Gonna go on the open. Normally open.
You also have the other side of your motor right here too.
That completes the power circuit.
So if we want to power up our time clock, it's a motor, so it's a load, right? So a load has to have both an L1 and an L2. So Jaylen, why don't you power up our time clock by us adding the neutral to it?
Yeah.
Yep. Okay. Connect to there. Does that part make sense to everyone? So we just powered up our time clock. So do you guys want to do the refrigeration circuit first, or do you guys want to do the defrost circuit first?
Let's do the refrigeration circuit.
Okay, snap photo
Okay.
real quick.
So, I mean, you have a few different ways of doing this, right? Because some units might go through your thermostat and your pressure switches. Other units might just go through your thermostat to power up the solenoid, and then the unit pumps down based off of pressure, right? So I think we're gonna do it that way. So let's just do our thermostat first. So now we have these two switches right here, normally closed and normally open. On most time clocks, so this would be 1 and 2. There's usually a little jumper. On the one downstairs, it's an older model, so 3 and 2 are actually down here. On most time clocks, like I believe Idaho Falls, your neutral is labeled N. On our one downstairs, it's labeled X. Then usually you have a 4 and a 3. Granted, there's usually an X too for termination, right? But we're not gonna worry about that right in a second. So you've got your normally closed, you've got a normally open. Which one of these switches up here are we gonna connect to our T-stack? Idaho Falls, guys?
You're muted.
You guys are welcome too, like if your guys' diagram looks nothing like this at all yet, you're welcome to like, draw.
Okay. You want me to? Well, yeah, we following your time clock.
Yeah, show us the link. I forgot time again. Or X-ray was suggesting. I'm trying to go over to the system.
You want me to draw this?
You can,
Yeah, sure.
but just tell us on ours, where do you connect?
So is everybody following what they're doing? L1 neutral or L2 neutral. Well, here we go.
And thank you everyone too for like being patient. It's not always easy like doing this on teams with like multiple branches, so trying to move at a slower pace so everyone can participate.
So if you guys can, Matt, have like Anthony or Andrew, Ellen, one of those guys, draw up this time clock and try and follow along with us.
Andrew, you want to draw?
Just so everybody's saying.
Joel, do you know right off the bat what side of this time clock your thermostat goes to?
No, brother.
So this is gonna be kind of interesting. I don't know if you guys can see this?
Yeah.
You guys can all see this, right? So this is in refrigeration right now, right? Not in defrost. No numbers on this, there's no schematic. So something that's kind of cool, and I'll show them too, is if you ever have a scenario where your time clock has nothing on it and you have no schematic, you can pull it out of the box, you can flip it over. This is your motor, right? Can you guys see that? So this is the motor on the time clock. A good way to tell where your power goes is your motor has 2 wires on it. One wire is going here. If you flip it back over, it's terminal N. One wire goes here. If you flip it back over, it's terminals 1 and 2. So that's how you know how your, that's where your power goes, right? So now you have your switches up here. You have this switch over here is open right now. And this switch over here is closed right now. I'll pass it all around so you guys can all see. But if we're in refrigeration right now, is this leg that's closed or this leg that's open gonna have power on?
It's closed.
This leg that's closed. So right now, if we have no other information, this clock should be in refrigeration. So our wire to our thermostat is gonna come off of this terminal. Does that make sense to everyone? So I'll pass this around. You guys can look at it if you guys want. So knowing that, Matt, where do we pick up our thermostat?
4.
Okay. Now we have a thermostat.
It's over here.
USB?
Yep.
All right.
Hey, how come you're flexing on us like that?
It's not a USB, it's a USA.
So wire in your thermostat from your defrost clock. Which terminal does it go on?
What, can you repeat the question?
What, you're wiring in your thermostat right now. Which terminal from the defrost clock does it go off of?
Thermostat goes on the refrigeration one, so it should be 4.
Is that open or closed normally?
Normally closed, right?
Okay.
So let's have Anthony draw that up on your guys' whiteboard.
What is it?
Anthony,
And if I can see your whiteboard, make sure you guys.
Dylan brought.
Right.
I think he's in the bathroom. How do you turn this around?
Huh?
Can you, can you,
flip it.
You have to flip. There's no.
Flip it.
oh, you have to turn the whole computer.
Yep. Turn the whole computer.
Okay, so.
Can you see our board?
First of all, your N needs to go to what? Yeah.
Neutral.
Line 2, yeah.
Because your clock isn't getting powered yet. You guys need to fix that, Matt.
Here, just erase that. Erase, except the numbers, the 1, 2, and 3, and 4.
Looks like to me somebody's cheating because you guys are ahead of what we got going on right now.
Here, let me.
It's my bad. Okay.
So in this diagram, we have our L1, so this is L1 as well, right? It comes off, the thermostat closes, says call for cooling. What is the where does it go from the thermostat? Cody says solenoid.
You want hot sauce?
Solenoid back to LC.
Andrew, do you like hot sauce? You gotta start bringing hot sauce.
Are Idaho Falls caught up to this?
Wire. Right here. It goes to your LC. Turn on.
Come on, Matt, get it together.
The pressure control wire.
I'm not here.
Well, that's the problem.
He's there. I haven't seen anything, but I could be wrong. The pressure controls are always up at the RTU.
Well, I'm here.
Now Shane's cheating. Nope, you guys aren't listening.
No, dude.
That's your drawing.
That's the drawing, isn't it?
We're not powering up a motor yet.
I thought you just said, where does L2 go to on the motor?
On the time clock.
On the time.
On your time clock, you need to power up your clock.
That's the time clock motor.
Oh. Oh, you're wrong than us. Our motor's on 1 and in. Right now, you're not even on your clock. It's okay though. Moving on.
Okay, right.
We got a bunch of cheaters over in Idaho Falls.
Oh, dude. Okay, hold on.
Going to our solenoid coil, from our solenoid coil where? L2. Solenoid coil.
Neutral.
L2.
Here, up to neutral.
Okay, happy with that?
Is that good?
Okay, that's good. Now wire in your solenoid from your close switch off the clock.
So it's LLC. Liquid.
I mean your temp control. Do your temp control first, then your solenoid.
I need a wiring diagram.
What we're doing. All right.
What's going on?
Okay.
It's hard to like, yeah.
What else do
Sorry,
we have
dude.
on our
It's all the
refrigeration
K2s
circuit?
that's spoiling me.
So go from.
What else do we have on our refrigeration
That's
controls?
normally,
Fan motors.
closed, right?
Normally closed is 4.
Yep.
These fresh controls.
Okay, hold on. Oh wait, we're not supposed to be doing this.
Oh, then don't look at it.
Okay. Tony wants to do our fan motor circuit. On a freezer, do the fans run all the time?
No, it's shut
They shut off during defrost, right?
We're gonna start with standard.
So where do our fans come off of?
Which set of contacts are normally closed?
4.
4?
4 is normally closed.
Okay. So we're gonna go.
So not off that.
You guys are too noisy.
Yeah, it's gonna.
Okay.
Three.
So fans, we decided run during refrigeration, but not during defrost, right?
Correct.
So Jalen Gordon says our fans come off of 4 as well for refrigeration.
Heaters are 3.
Then we also said on our list, we were gonna use what?
A relay? We have relay? No.
We didn't say everything.
The defrost contactor?
Yeah, but that's on the defrost side.
Pressure control.
What else did we say was with our evap fans?
They contacted. You got
Fan switch.
A fan relay, like a fan delay, right? Because you want your fans to turn on right after defrost when the coil's 100 degrees?
What?
Because we didn't install the KE2 yet.
Let's go. What's Shane that? Let's go, Shane.
But really though, if you think about it, if your freezer comes out of defrost, the coil's hot, the heaters are hot, and you're in a low temperature application like a freezer, would you want your fans to turn on right away?
No.
That's what the click's on. for.
So there's lots of ways to do it. There's a clicks on, right? You can use a clicks on. They've got like a 3-wire that does termination and fan delay, or a simple thermostat wired opposite of your regular thermostat would delay the fans, right?
I have a side question.
Yeah.
So it's like the variable speed fans, is that the same thing? When it
No.
turns on real slow?
Not really. It's just like starts at a slower speed and they can adjust speed
Okay.
based off of like box temperature, and it's more like an energy efficiency type.
Okay.
Cody?
It's actually when the, so this is a tangent, but the 2-speed coils, it runs off the T-stat. You send a separate power leg off the T-stat, so when the T-stat and solenoid are energized, you're high speed. When the refrigeration system's off, and the T-stat's off, low speed fans. That's all it does. It's just.
Figured out the hard way.
So we have our fan delay also coming off refrigeration, right? And that goes to what? Jalen Gordon says fan motors.
Complete opposite.
And the other side of the evap fans goes to
L2.
L2. Is everyone up to that point? Does that go false surviving?
I muted them, so.
Okay, so what else was on our list of stuff?
Defrost.
Contact.
You guys are muted because you're being too loud, but if you do have questions, unmute yourself.
Compressor?
Compressor, which is gonna be a low circuit, right?
Mhm.
Not a control circuit. Is our defrost heater a load or is it a control circuit?
Control.
The heater is,
It's a load.
Oh, yeah, just.
but our defrost contactor though is part of the control circuit, right? So you have controls and you have like line voltage, you know. The motors are part of the control circuit because they're being powered up by parts of our control circuit, right? The compressor, for example, the control circuit energizes the contactor, which just allows voltage to go through to your motor. So let's do the defrost. So defrost comes off of what terminal on the time clock?
Trace.
Okay. And it goes to what? According to the list we gave. The defrost contactor.
Correct.
What symbol should the defrost contactor be?
2 lines.
It should be almost 3 lines. That's what it says.
2 lines.
2 lines?
2 lines.
Why?
The contactor, it's normally open.
But you're not passing voltage through the contactor. You're powering up the contactor.
So
you're
power
coil.
The coil, sorry.
So it'll be a load. Right?
Yeah, so this is our defrost contactor coil. So it goes into defrost, it sends power to our defrost contactor coil. The other side of our contactor coil goes where? Joel?
To the pan heaters.
This is a coil.
Then it goes right back to neutral. L2.
Over to L2. When you guys were talking about like the heater and stuff, you have like your contacts, right? It's just called like your wire going in. Then you have your coil, which is usually 2 wires on the backside, right? When your time clock goes into defrost and energizes your defrost coil, that's what closes this contactor and then sends power to your heaters. It's the same concept for like a compressor too. In this scenario, your thermostat calls, right? Your solenoid energizes, your pressure starts going up on your condensing unit. Contactor closes when your pressure goes up, sends power to your compressor. So you can see why we're not including this stuff in our control circuit. Because if this is energized, your heaters are on, right? Or supposed to be. And if this is energized, your solenoid's on and you should be in refrigeration. And if this is energized, you know your fan delay's closed.
Can
So
we
even-
clarify?
What?
Can we clarify something real quick?
Yeah.
All the L2s, those are getting wired to the N on the time clock, right?
Yeah, or a big wire nut in a J box, or,
Yeah.
you know, sometimes you have different, you have like a neutral at your evap, you have a neutral at your condensing unit. It's just showing that it's neutral. But if you did wire all your L2s and shoved a bunch of wire nuts on that N terminal, it will do the same thing.
Yeah, my name on it.
But does this make sense though, why we're not including that in a control circuit? Because a heater is a load, right? And a compressor is a load, right? And so is a defrost coil, evap fan, the solenoid, your time load. But we're not including these in the control circuit because it's not really relying on a control to do things. It's just passing voltage through your contactor based on whether or not your load here is energized.
Smart power, dumb power. That's how I look at it.
So does everyone understand that?
Mhm.
Are we missing, what else are we missing from our list?
Let's find out.
Missing.
How can you guys see that whiteboard now? Pretty good? Shane?
Compressor circuit, compressor control circuit.
What's up?
We see like we're good.
Yeah, can you turn the camera a little bit to the left?
To the left, to the left.
Oh, to the right?
What you got?
Right there. That's better. Thank you.
That's a cold camera.
So Jay Lynn said we have not done our compressor control circuit yet. So there, like we said, there's 2 ways to do it, right? We could very easily put like our pressure control here, right? And you can, there, you've seen it run through pressure control thermostat. But in this scenario, we decide we're gonna run them separately because a lot of times your thermostat's located where?
In the box.
In the box. Your solenoid coils might usually where?
In the box.
Where's your pressure switches usually located?
In the condenser.
In the condenser. So why would you want to run wire between the condenser and the evaporator if you don't have to,
I don't know.
right?
Yeah.
So in this scenario of all this, what's the first part of our compressor control circuit?
Disconnect.
Well, you got to disconnect, so we can draw that, right? Except for usually it's probably here.
Yeah.
Right, if our disconnect's on.
Mhm.
Disconnect.
A disconnect.
So yeah, you're right. Your disconnect's here, right? Because if you shut your disconnect off, you're killing everything, right?
Yeah.
Or if you really wanted to, you could not put it there and you could put it down here, right? You could put it here. That could be your disconnect. If you put it up here and you shut the disconnect off, it's gonna kill everything, right? If you put it down here, you're not killing power to your control circuit, you're just killing power to your condenser. We'll just put it up there at the top for now. So what's the next part of our compressor control circuit? Compressor. Before Christian says safeties, low pressure, high pressure, right?
Yeah.
Where are we gonna put our low pressure and high pressure switches on this diagram? If our evaporator is downstairs and our condenser is upstairs, where do you guys want to put our high pressure switch? So Matt's saying on the roof, which is fine, but where on this diagram do we put it?
Just off L. Yeah, right below the.
Are we gonna tie it into 4 because it's part of the refrigeration?
Put it after the salt. Well,
What do you think?
That was its own.
So it would make sense, right? Because it's part of refrigeration. What about Idaho Falls, guys? Are you gonna put your high pressure control after 4 on your time clock? I mean, it's all part of refrigeration, so is that where you want to put it? In this scenario?
Seeing the control, I seen pressure controls wired in series, like the low pressure and the high pressure, like on the same line.
Which we're gonna do,
Okay.
but we're gonna start with our high pressure. Dylan. I haven't
Yes,
heard much
sir.
from you today. Where are you gonna put your high pressure control? Are you gonna put it on 4 of your time clock, or are you gonna put it somewhere else?
Yeah, I think you would, because that's your refrigeration, right? So if it's going to be cool or open, it's gonna keep your refrigeration from turning on.
Okay, but isn't that what our T-stat and solenoid's doing?
Yes.
If we go into defrost, we lose power to our solenoid, right?
Correct.
If our T-stat satisfies at box temp, we lose power to our solenoid, right?
Correct.
So what does your compressor do when your solenoid de-energizes? What do you? It pumps down. So it really doesn't do you any good putting it here because you have all these other controls that are gonna shut your compressor off. You have a solenoid and a thermostat and a time clock that are all gonna shut your compressor down when it pumps down on low pressure. So earlier, Cody said you're gonna run it right off of L1. So we're gonna bring L1 straight down here. Now essentially we're on the roof. So then we've got
Pressure, high pressure.
and we got our high pressure control. What's after our high pressure control?
Low pressure control.
It ran a series.
After our low pressure control. Idaho Falls, guys, what's after your low pressure control?
Contactor coil.
Good job, Shane. So now we have our compressor contactor coil. And the other side of our contactor coil goes where? L2.
That's what I was talking about.
Sometimes it's like one.
Yeah, they do. Oh, shit.
So it's condenser circuits total.
So I think that was everything on our initial list, right?
That's beautiful.
Is this used?
Does this make sense to everybody?
It looks seasoned.
Sure do.
Guys in Idaho Falls, does this make sense to you guys?
Makes sense, guys. Makes sense.
Yes. What's the C set? Oh yeah, compressor.
So evaporators control and then condenser controls.
Yeah, low pressure, high pressure, low pressure.
Yeah. Yeah.
No, throw away 230.
Ah, see that.
Come on, man. They just share a neutral. It'll be fine.
We're gonna get to that.
Oh, we are? That'll be dope. We got
Okay.
a 2-way plug down there?
So now that you guys have our diagram, you're checking stuff right now, right? We're gonna start with like something fairly simple, okay? Your box is at -10 degrees and it's satisfied and it's pumped down and shut off, right? If you were to take your meter and go across your T-stat, if the system's satisfied and pumped down, Jalen, you know what your voltage would be right there?
Across the thermostat.
120.
Satisfied, it's pumped down, it's not running. So what is your voltage across your thermostat?
120.
Who said that?
Andrew.
Andrew says 120.
Does everybody agree with Andrew?
I agree with Andrew. Yes.
No.
I say it'll be 120.
Yeah.
It'll
Oh,
be,
wait, reading 120?
Pump down right now.
No, you're gonna be reading.
So we're not in defrost. We're just satisfied on temperature.
What is the contact to in
When it's
thermostat?
when it's satisfied.
We're just shutting off the solenoid, right?
yep.
The unit's
Can I ask a question? Is your thermostat a switch or?
Zero.
We have 120 going to the L2, 120. But when it's satisfied, when it's running, it's normally closed.
When thermostat is satisfied, is your thermostat open or closed?
What you got on either side?
Open?
It's gonna be open. Yes.
Idaho Falls guys, do you agree? If you're at temperature and your thermostat is satisfied, is the switch open?
Yes.
So on a 100-volt circuit, if your switch is open, does everyone agree that you would read 120 volts across that switch?
Yeah.
Correct. Yes.
You're measuring.
Yes.
Basically, the other side, if
So you're on the same line of power, right?
Yes. It's a switch.
So now it's warm, your thermostat closes, refrigeration turns back on. If it is running and it's warm and you're calling for it, what is your voltage across the thermostat now?
Big old fat goose egg.
Goose egg.
Goose egg. Yeah, the goose egg.
Does everyone agree that if your switch is closed, you read 0 volts across it?
Big old goose egg. Yep.
But if you read 0 volts across it, maybe you're confused, you're like, oh, I don't have power. If you were to check this terminal to ground, what would your voltage be? 120. If you were to check this terminal to ground, what would your voltage be?
120.
And if that's closed, what is our voltage across our solenoid coil?
If it's closed, it's gonna be 120 because the solenoid is
If you're testing L1 to neutral, it should be 120.
that should be 120.
Yeah, because then it's a low.
Be 0 if you test it on the same side.
Hold on, let me.
Yeah, it's close. Thank you.
If it's closed, like, for example, if you was to go across, the T-stat right now, it's 0, but the only reason it's gonna be 120 across the solenoid coil is because it's a low and the thermostat is a switch.
Yeah.
This would be no different than taking your meter and sticking it into an outlet in the wall.
Facts.
120 volts.
Just try with a fork.
You got L1, your power, L2, your neutral. If a load is energized, you have voltage at your load, right?
Factions.
If your switch is open, you have voltage across your switch. If your switch is closed, you have voltage through your switch. And the way someone explained it to me, right, is if the switch is closed and you have 120 to ground on both sides, you have 0 across it. The dumb way it was explained to me is power's not going through my meter because it's going through the switch. If that switch is open and power can't get from here to here, it's going through my meter. Now, whether that's technically correct or not, when I first started, I was like, I don't get it. I got no power. And the guy was going through your meter. So now as we shut our disconnect off and we wanted to check our ohms, right? If we checked across here and here and it said, oh, well, our switch open or closed.
Same concept though.
We went here to here and it went beep, is it open or closed? Does that concept make sense?
It does.
But if the load is energized, you have voltage across your load. If your load is de-energized, you have 0. If your switch is closed, you have zero. If it's open, you have voltage.
Yeah, it makes sense. I mean, I just,
There's two
places of contact. When you wrote it to
Okay.
switch.
That's kind of like a the fun thing. Let's just say now that this is 230 volts, okay? If, we'll go back to 120 for a second, right? If this is open, right? If this thermostat is open and it's 120, what do you have to ground here? 120, right? Because that's your hot light. If it's 120 volt and your switch is open and no power is coming here, what do you have to ground here?
120.
Zero.
If it's open?
You said 208 or we
No,
said
we're still on 120.
Oh, okay. You said 208. You threw me off. Whatever.
Okay, so if this is 120 volts and this switch is open, we'll have 120 to ground going into the switch, 0 ground going out of the switch. So now say, for example, this same switch is 208, 230 volt. If this switch is closed and you're checking across it, what do you have?
Zero.
Zero. It's still closed, right? Regardless of whether it's 120 or 208. If it's open, what do you have across it?
120 on both sides. You're gonna have 120
Across it.
Oh, across it?
220. So now if this is open, right, and you don't have, your switch isn't closed and it's 208 volt. Joel, what would your voltage be to ground here on a 208 volt circuit?
208.
Would it? What does everyone think? Would you have 208 to ground right here?
No.
No, it'll be 120.
Who thinks 120? Jalen?
Yes.
Matt? Why?
This is very short.
So this is just the ground, right? So it's 208 volt.
Yes, you have to have a load before you.
What do you have to ground on this side?
The switch has a load, because the light bill.
120.
Consumes
So 208 can be confusing. I made a stupid mistake when I started. The unit wasn't cooling. I went up there and I said, my solenoid's energized. I don't understand. It's not closing. The solenoid valve's not closing. Not getting any refrigerant through it. Boss is like, what's your voltage on it? Me being a pansy, ended up getting shocked. I was afraid to take the wire nuts off and go across it. So I went to ground on this side, and I went to ground on this side, and both were 120. And I said, I don't know, solenoid's energized. I've got power on both sides. And he said, were you checking across it or are you checking to ground? It says to ground because I don't want to take the wire nuts off. He's like, Dustin, stop effing checking to ground. So if it's 208, you could check the ground on either side and still have voltage. Because with 208, it's always backfeeding. You always have 120 somewhere. So just as a habit, checking the ground is like a good way to tell, like, is it hot? Is it, is there power here? But if this is 208, it's going to be the same if it's closed, you still have 0 volts. If it's open, you're going to be reading 208 or 240, but you're always going to have 120 to ground. Does that make sense?
Yes, sir. I like it.
So it's good practice then to just kind of, take one lead of your meter on L2 or neutral, regardless of voltage type, and just pop stuff down across all of your loads and switches. See what it reads.
So here's sometimes too, like things are in like tight wire nuts or something like that, or things are all bunched together. There's other ways you can like check to see if things are energized or open or closed. For example, here's our T-stat, right? We have power coming up here to our T-stat, and then our T-stat goes to our solenoid coil. What if wherever we're at, all we can access right now is our solenoid coil and our time coil? How can we verify if that thermostat's open or closed?
Check voltage at the solenoid coil.
We can't access this, right? Well, we know our solenoid coil is not energized. But let's say you can't access the thermostat for some reason, and you need to figure out if your thermostat's calling for it or not. Is this supposed to be energized or not? So you can't access this or you can't reach it.
All right, I know what you do.
How would you tell if this is open or closed?
You disconnect leg 2 from the solenoid and then check power at the solenoid to ground to see if it's got 120.
Well, if this is 120, but what if it's a 208 volt circuit?
Can't you check,
Check on time clock, can't you?
Yeah.
Execute.
How is it checking from 4 to this side of your solenoid coil any different than checking directly across this switch? I mean, you're not always gonna encounter that, but sometimes you're gonna, like, some of those rooftop units, right? Those wires are everywhere for those pressure switches. You can read the wiring diagram and say, I wanna know if my high and low pressure switch are closed. You could just go from your thermostat all the way past both pressure switches, and if you're open, one of those two switches is open. If you're closed between here and here, both of those switches are closed. Does that make sense?
Yeah.
So just like a diagnostic tool, like,
I see what
you don't always necessarily have to go piece by piece by piece. You can look at your control circuit and say, if I have power across this, everything before that is closed.
Cause you know.
If I don't have power across this, something before that is open.
Hey, can you just check power between neutral and 4 at the time clock?
It depends on what's all in there.
Well, what does that tell you really? You have a solenoid on there, you have an EVAP fan on there. I mean, you can check it. But I've also had two where a time clock looks like it's in defrost, or it says it's in defrost, but I don't have heaters. Right? What would be the first place you could check to see if your heaters are energized? I mean, we know they're not energized, right? But do we know why? What if your time clock, what if this switch didn't close, right? If you are in defrost, what should your voltage be between 1 and 3?
120.
If this is a 120 volt circuit and you're in defrost.
0.
Who thinks 0 and who thinks 120?
0.
Does everyone agree that if you're in defrost between here and here would be 0?
Yeah.
Because if this is in defrost, this switch is closed, right? That switch is no different than that switch or those switches, either open or closed. Same thing for refrigeration. If nothing's working on your refrigeration and your time clock says it's in refrigeration, between here and here should be 0. Right? If you put it in a defrost and your heaters don't turn on, what if you have 120 across here?
Assuming it's not powering it up.
So that time clock, right?
Mhm.
So you can kind of go through your circuit. If you look at it that way, like this is pretty much a walk-in freezer, right?
Mhm.
Just by like knowing like this stuff and the basics of it, like really everyone in this room should be able to like diagnose like a control circuit on a walk-in freezer. And a cooler is even easier because you don't have the heaters for, probably since you're a beer cooler, but you don't have the heaters, you probably don't have a fan delay. So if you can kind of grasp the concept of anything along this is L1, and this has to be closed, that has to be closed in order to energize that. Really, everyone in here can diagnose like an electrical control circuit. That make sense?
I have a question. You'll probably derail us because we don't have to freeze them out the cooler though. But if you would let me ask,
You're fine.
Okay, give us like a air defrost like situation. Like we got defrost heaters here, but say like there was a walk-in cooler and goes into defrost and you still got your evaporator fans going. So it would kill the solenoid, it would kill like the refrigeration, but it'll also keep the fans running. How is it also keeping the fans running?
So Jalen's asking if this was a cooler that the fans run during defrost and there's no defrost heaters, what would it look like?
What did you just erase? You're back with something. What was that? Well.
Except for, is that right or not?
There we go. Okay, we just take out the whole, yeah.
Still not right.
When it goes into defrost, it opens and normally closes. The fans are on its own load, so you would eliminate it off of full.
So if we just got rid of our defrost heater and this is a cooler, we got rid of our fan delay, right? So there's no temperature control keeping the fans.
That fan is still going to the refrigeration.
But it does
kicked off.
Does everyone agree that that's incorrect?
That is incorrect. I see why now.
So where would we hook up our fans in this scenario?
To 3.
Line side.
Well, will they be jump between 4 and 3?
Would you hook it up to 3?
No.
No.
It would just be the line side. You wouldn't hook anything up to the defrost. The fans are on its own separate circuit.
Gotcha. So it would.
Hey, Matt, can we have Anthony answer this question?
Go for it. You're on the spot, bro. I didn't hear the question. What was the question?
Want to repeat it?
You want me to repeat it? Or?
Okay, if this is a walk-in cooler application, which, point off of the time clock would your evaporator fans be wired to? Right now, they're wired to 4. Is that correct?
No,
Which is on refrigeration. So where would they be wired to?
they would just have direct power, right?
No.
Why? Because wouldn't they?
X. That's what that switch right there is for.
It would be
Okay.
wired like
Are you sure you're telling him correctly, Shane?
What?
Because if it's walking cooler, then you're.
We're talking about a cooler or a freezer?
Cooler.
Cooler. So the fans don't shut off. They're constant.
So they'd be
on a
all
cooler.
one, right?
So, yeah, they'd go to your terminal board, but they'd basically be wired to be running 24/7.
Okay, so in this scenario here, let's just do like a scenario. And let's pick on Cody, because he's fun to pick on sometimes. Cody's wiring this up, and he knows he has his L2 already hooked up for his EVAP fans. Maybe he's taking a freezer and turning into a cooler. He wants his fans to run all the time. He says, all I gotta do is connect it to L1. I don't even need the time clock. So what if he's like, well, this is L1 right here. Is this L1?
No.
This isn't L1?
But it's gonna kill if those pressure switches go out.
So if I hook my fans there, I hooked it right up to L1, right?
No.
But if the thermostat opens, or the solenoid coil de-energizes, and my system pumps down and those pressure switches open, my fans turn off, right?
Factual.
Does that make sense?
Wire it before the safeties.
There you go. Yeah, there we go. He said no.
Just like that, it's fine too, right? It's
Yeah.
before the safety.
Yeah.
No matter what status this is in, refrigeration defrost, your fan should be running. Unless Jalen leaves the disconnect off on the fan.
Hey,
Don't judge me.
Yeah.
can we touch on parallel versus series wiring when it comes to this control?
I didn't tell him that. That no come from.
Job security.
Well, we can a little bit right here, right? You have your EVAP fans.
Making work since 1990.
And you have your compressor circuit down here, right?
Yeah.
Was that a parallel circuit or a series circuit?
Wait, repeat that.
You know,
You
between
have
a
this right here,
parallel circuit
and
versus
you
a
have
circuit.
this down here. Is that parallel or in series?
Runs through things individually,
Series.
right?
I was
It's because it's in the same.
I would
Series.
say parallel.
Same
I would say
So series is when you're running the hot link,
The one sentence someone's asked this.
and if one of these opens up, it kills the whole circuit versus parallel.
You're running into each one.
If one of these goes off, it won't affect your other load, because it's in
Right.
parallel.
So your compressor unit fan would be parallel.
Mhm.
So if you leave
So how
compressor-
that's wired right now, yeah, the fans, they're wired in parallel compared to the safeties.
Okay.
So
But
you
then all
can
the
see,
safeties. are
what
series.
does parallel mean, right? Two straight lines that are like identical to each other. This circuit and this circuit are parallel to each other. It does not matter. The fans will run regardless of whether this opens or not. But this high pressure control and this low pressure control are wired in series. Because they both have to be closed to send power to your contactor coil. So series is one component after another. It's in series. Parallel is, these are both using the same power source, but they're independent and parallel from each other. This does not have to be going for your compressor to run. Your compressor does not have to be going for your fans to run. Does that make sense?
Yes, sir.
So if the pressure controls, say you're diagnosing it to verify it's a bad one, it's supposed to be closed, but you've got voltage across it. If it's closed,
Across your pressure switch?
yeah, then you could say,
So
that's how
let's
you
say-
could verify.
Well, if you have your pressure switch is closed, would you have voltage across it?
Okay, so if it's open.
Okay, if it's open.
Yeah.
Yeah, you would have voltage adjusted.
How, dude?
But. Explain. But also, if for your pressure switches, if you want to test and see if it's bad, say like it's supposed to be running right now, you can isolate the wires that's coming from the pressure switch and make sure it's powered off. Well, it's gonna be powered off if you take it away from the circuit, but you can go into resistance and take your meter and you'll know when you go through it, if it's saying OL, you know your pressure switch is open. But if you get that BP was talking about, you'll know that it's closed going through.
Yeah, so that's a good point with series and parallel too, right? If this pressure switch is open, do we still have 120 volts here?
Yeah.
Yes. If this pressure switch is open, Jalen Simmons said we have 120 volts across there, right?
Yes.
But if we check this, are we even gonna have power there?
No.
No. So you're not gonna have any voltage there, right? Because it's 120 volts. The voltage stops here where that switch opens. So this switch will have 0 to ground, 0 to ground, and 0 across it. But is it open or closed?
Oh, close.
0, I don't know.
Oh, yeah.
You have to switch over to your own meter because there's no power there. So on a series circuit, this is 120 volts. This has to be closed in order for this to have 120 volts going to it. Where other way around is in a parallel circuit, both of these can be open. You can just rip them out of the circuit, whatever, just leave the wire game on there. And your fans are still gonna be running because they're tied in over here.
We never ran into that and somebody just bypassed the pressure switches already. That's crazy. Why would somebody do that?
So
I have a question. If you were installing two separate pressure controls, it's not a dual. Would you wire in your low pressure control first or your high pressure control first?
I don't think it matters.
Or-
Doesn't
I don't know.
matter because they're in a series.
yeah, I don't say it doesn't really matter too much, but I was always taught like, and I think on diagrams, usually highs first.
You would do your high for the safety reason of it going over that pressure.
Yeah. But even in theory though, even if you put your low first, if your low is closed and it hits your high, if it's open, it's open. You know? But normally the high's first, is why we drew the high first. Because it is, if we have a back condenser fan motor, right? If the low pressure control is first, every time it starts cooling down, this thing's just gonna go off on, probably more frequent. But if your high pressure control is open, you know, it's not gonna just keep going off on, especially when it's 100 degrees outside.
You just got a fan cycle switch.
Travis or anyone else that's smarter?
Dustin, can you repeat that last part?
Just in general, you're supposed to do the high pressure switch first. It really does not matter. It does the same thing. But it is, would you rather your compressor be running in a vacuum or running at 500 PSI?
Neither.
Probably neither. It's probably safer to run it in a vacuum than it is to run it at 500 PSI. But same thing we talked about. Doesn't matter. If this one's open, it's not even gonna power up that one. That one's open. This is still closed, but it's still shutting off your contact. Does anyone have what stuff they want to add, or Travis, do you have stuff you want to add?
I think, one of the good parts that I think maybe Shane mentioned was the clicks on. So if we could just draw that in, off the X terminal and to your fans.
Okay. So like a termination. Okay.
That was on the eval line.
So where are we gonna put our, well, I guess we better draw our thing back in here. I get to it.
I just want to say this was really good and I appreciate it.
Who wants to take a guess on where we put our termination fix on? No, it's off the X, right? Where's that time clock at? So this thing right here is your termination. It also has two wires coming off of it, just like our motor did.
You want to show them on the camera?
This thing right here is the termination on this time clock. It's a load, right? It has two wires coming off of it. You have one wire coming down here to your X terminal. And you have one wire coming over here to your defrost terminal, right? So we already know our defrost terminal is L1, correct? So if we wanted to put a termination here, where would you guys want to put it?
Put it on UDEP.
Hmm?
Put it on UDEP.
Well, if we just wanted to like terminate our defrost.
Terminate the defrost.
Mm-hmm.
Before the defrost coil?
So you want to put it before the defrost coil? Because we have, this is a load, right? This is L2 and this is L1, right? So somehow we have to have our termination end up at X.
So after the coil.
Okay, so let's put it after the coil. What kind of switch is our termination? Temperature. That's got me nervous for this one. I'm out of the termination. We gotta terminate, we got a 10 sensor here, right? So right now, let's just say, I think it would be drawn this way. Right? Maybe.
Wouldn't that be considered a switch?
Maybe close on full.
Maybe. Close on.
I think it'll be a close on rise because like when the temperature is sensitive, when it senses that it's a high enough temperature.
Well, if it's just a
It'll
click on,
close.
it'll be.
Are we talking about the clicks on?
Yeah.
It's closed on fall.
Yeah. Wait. A close on the
Open
fall.
on rise, close on fall.
Because it
Opens
gets
on
colder,
rise,
and
closes on fall.
And then defrost termination will be open on.
I'm thinking like if the box gets hot enough, that's why it was be like, okay.
No,
we're gonna
it's just, it's
close.
on one of the
I don't know if I'm right.
I never put
The
one.
way I think about it is we have to energize between here and here, right?
Mhm.
So if this closes on fall, it completes our defrost heater circuit.
Mhm.
If it opens on fall, or if it opens our defrost circuit, right?
Mhm.
Well, let's just say, for example, because I don't think this is right.
But that, okay.
If
that's
that was right there.
You're right, yeah.
If that was right there, and this switch opened, would we complete our circuit back to here?
No.
But if that switch is right there and it's closed,
We'll complete the circuit.
but we're also completing the circuit here, right?
Correct.
So when this switch closes, your termination closes, so it closes on a rise in temperature. When that switch closes, I don't know.
That's the best answer I've
I actually think it's right here. Right now, our defrost heater's on, right?
I think responsible. I don't know, but I'll figure it out for you.
I think it's right there.
Okay.
Because now if we're in defrost, right,
It'll still complete that.
our defrost heater's working.
Mhm.
If it gets warmer, it gets warmer, it gets warmer, this switch closes, right? When that switch closes, it sends the L2 back to our X, which energizes that little solenoid thing on that time clock, which forces the time clock out of defrost, recloses our refrigeration switch, and just opens the switch altogether. So once this switch opens, it doesn't really matter if that's open or closed because you no longer have power going down.
Question, why would you need that whole line, right, if you got power going to that motor? That motor should be kicking it out of the defrost.
This is the motor. This is
Right.
the termination clicks on.
Yeah. But what I'm saying is like the motor is gonna be sending, like, depending on where it's positioned at when it opens or closes those contacts, it's gonna be sending it to. Right, but when you put in the pegs on there to determine the defrost, it's gonna be sending.
So what
power
is
between the-
the time on your, defrost clock.
Termination closes on rise.
Yes.
Yeah.
So what if you were testing defrost? You set this for 110 minutes, right? The timer is a fail safe. If termination is hooked up, if it does not terminate on temperature, it will terminate on time. You could set this for 110 minutes and put a 42-degree termination. Clicks on thermostat, whatever it is right here, right?
I see what you're saying.
So if this is set for 45 degrees and this is set for 110 minutes, chances are it's gonna reach 45 degrees before 110 minutes. So when it hits 100, when it hits 45 degrees, this closes, it comes all the way back to your X terminal, which energizes this little thing. You see how there's that button thingy down there on the bottom? It doesn't matter what time of day this is set for. Once this energizes, it force opens the defrost contacts on your time clock and it recloses the refrigeration contact.
I see exactly what you're saying. So the timer is secondary to.
I was just-
clicks on.
I was just thinking about this just based off of something you said, and I actually never thought about it in the field, but when I've had a clicks on fail, technically, you could take a regular ABC 19 and instead of wiring it up by opening and closing on rise and fall, you wired it to the other two where it closes on rise.
And that's what we
And
did on our
throw-
thing downstairs with our fan delay.
And throw that probe right in your coil and you guys got a defrost termination.
Which when we go downstairs and look at the trainer board, we've got two identical thermostats. We're using one for our box thermostat, and we're using one as a fan delay. The only difference is we wired one up to be normally closed and we wired one up to be normally open. So when you wire up a thermostat, I'll admit, I've done it before. I put in a new thermostat and just said, oh, this one's on the top and bottom. I'm gonna put this one on the top and bottom. Didn't realize it was a different brand, didn't realize it was a different switch. So I actually put a thermostat in that closes on a rise of temperature, opens on a rise of temperature instead of opens on fall of temperature. So I plugged it in, turned it on, it started working, pack up my stuff. An hour later, they call me and say it's getting warm again. I go back out there, my thermostat's open because I wired it to close on fall or close on fall and open on rise. So now that I've actually drawn this for like the first time in like a long time, I'm pretty sure that this is where the clicks on would go on a wire feed diagram.
So if the clicks on fails, just a field repair.
You can take
Cut the wires and wire it together.
Or just.
Eliminate
that central goal.
So if you wire it together, like Cody said, in this scenario, let's say this fails and you just take this,
Ace.
wire it together.
Clicks on, not the defrost termination. It won't work on defrost termination.
But if you did do that on this one,
Clicks on,
what would your defrost look like?
it would just be time.
Would it?
Would you ask?
Yeah, if this failed, and so you nutted this wire and this wire together, what would your defrost look like?
It'll never go to defrost.
Issues.
You have to separate those two wires.
You never have defrost.
Yeah.
Terminate all the time.
Every time this goes into defrost, it's gonna send power right back up to your termination and kick it right back out.
You separate those.
So if that did fail, you just separate it all together. You can run it off of time terminated until you can get back to replace the termination. The reason why freezers use the termination is usually when you walk into a box and there's icicles all over the ceiling. A lot of times it's because the defrost is too long. So that's why freezers have termination clicks on them. So that it terminates on temperature, not time.
So at the time clock, how could you tell you got a bad terminal or termination?
Well, you're gonna have really only one scenario, right? Because if this fails, you're gonna terminate on time, right? So there's gonna be two scenarios. The most common one I see is this sticks closed. Back years ago, I was working at a Maverick. The first tech went out there and said, it's iced up, it has a bad time clock. So he replaced the time clock. The next few days later, a different tech went out there and said, you are not gonna believe this time clock failed again. Same thing, iced up. He de-iced the freezer for a second time. He called GA Larson and said, this time clock is bad out of the box. He took that time clock back and got a warranty time clock. He put that in. A few days later, Rockstar up here gets a call. Okay. I go up there, I put it in a defrost. I reach down, I grab my meter, I put it on my amp, I put my amp clamp on my heaters. I'm like, there's no heat. So then I'm checking here and here between 1 and 3 because it's in defrost, right? So I should be reading what if it's closed? 0. I was reading 120. So I'm like, what the heck? So I twist it again because sometimes you over twist it, right? When you're twisting those time clocks and you accidentally skip the defrost. So I do it again. Pick up my meter, I go here, 120. It's still open. And I'm like thinking to myself, I mean, there is no way in hell that this is the third freaking time clock.
Yeah.
So being the smart guy that I am, I said, I wonder if the termination's bad. I took this wire out of the X terminal of the time clock altogether, just pulled it out, put a wire nut on it, and put it back into defrost, reached down, grabbed my meter, 0. Defrost heater's wrong. So in that scenario, my clicks on was stuck closed. So every time that sucker hit defrost, the stupid time clock kicked it right back out. If this fails open, what's the worst that happens?
Goes off time.
Goes off of time. So really, I mean, if all of a sudden your defrost is good, right? There's no ice in the box, it's running good. You were there on a PM 3 months ago, the box looked great. You go back this next PM 3 months later and there's icicles everywhere. Yeah, this is one thing that you can check. Set your time clock for 110 minutes or whatever, throw it into defrost and watch it. If all of a sudden your box is at 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees. But if you check across this, what would you have if it's open?
0.
0?
Oh, no,
It would be 120.
120, because this is the same leg of power, right?
correct.
So if you go to a freezer call and you see ice all over the box and you throw it in defrost and that X terminal is hooked up, there's a good chance that this here is not closing when the temperature rises. If you go there and you de-ice a coil and you turn it on and you're like, okay, I got the coil de-iced and my superheat's good and there's no air and they keep the door closed and everything else. It's very important to ensure that this closes on temperature if it's hooked up. Or you're either gonna be not defrosting long enough, or you're gonna be defrosting way too long. Did that like help like you guys with like when you think of like past instances of de-icing a freezer, or maybe things we didn't check or things we could add to our list of stuff to check?
Absolutely.
Is that clicks on in the evaporator side?
Yeah, it's usually mounted to like a U-bend or,
Yeah.
but like Travis said, we could grab a regular 3-wire thermostat and just wire it to close on rise of temperature and stick the thing in the coil and it would do the exact same.
Yeah. Wait.
Everyone good?
I like it.
East Idaho, do you guys have any questions on that?
I would encourage you guys to draw the termination on your wiring diagram, just as like a reference point.
And if it's a 3-wire, that one's just going to the
That's what,
fan.
that was my question. Where does the third wire go on those? 'Cause I've seen,
Well, this is a 3-wire. One's for your defrost, right? And one's for your fans. And because it's a switch, right, it's all the same leg of power, so it's not L1 and L2. It's either all L1 or it's all L2. So like in that scenario, you have your defrost termination, which closes on a temperature rise, right? And you have your fans, which closes on a temperature fall. So I think in theory, it kind of would look like this. You have your common, right? And you have a switch here, switch here. This is common. This is defrost termination. This is fan. After defrost, your temperature starts dropping, right? This switch closes on a fall in temp, it gets colder, that switch closes between here and here, your fans turn on. During defrost, it starts warming up. This closes on a rising temperature, it gets super hot. Now the switch closes this way and it terminates your defrost. It's just like a, what would you call it, like a dual throw switch or a double throw switch?
Single pole, double
Single
throw.
pole, double throw.
Yeah, that's what it'll be.
Single
So
pull.
I'm just curious too, like, after seeing this diagram, whether, how accurate it is to the manufacturer, who feels like they were like fairly close to this right off the bat?
God, no.
I had like two.
But seeing this now, I mean, it's okay, like, I mean, electrical is tough, like, we always are looking for a wiring diagram, right? But if you walk into a new customer and there's just wires everywhere, and you don't know what goes where, but you know your thermostat's here, and you know your time clock's here, and you know your pressure controls are here. Like, I've had to do it before, not sure what the heck is hooked up to what. Just rip all the wires out and start over. But now without a wiring diagram, you guys hopefully feel comfortable enough that you could see your components, know where everything's at, and draw your own diagram and wire it up for you.
That's what I've always done on jobs is I like, where it's been that confusing, you guys start back over from scratch. Even if it's tracing wires, like I've just sat down in the van and drawn up my diagram, you know, a basic wiring diagram, and then I went back, you know, and started like, okay, so this one's here, this one's here. And then you kind of figure out what's going on.
I go in.
How do they
I
do
go in,
that?
I look, I be like, I see what's running and I know what's not running. And then I just start, I know what you're supposed to be doing right now and you're not doing this. So I'm gonna start right here and see what's going on with that.
So we're an hour and 50 minutes into it already. You did a fantastic job on the wiring diagram. But I think it's time we have a little fun.
Yeah.
The guys get their meters out.
Funky.
Let's see if Wyatt gets shocked.
Oh, it's gonna be fun.
It's a Sparky. I've shocked myself enough.
You say
I'm good.
meters or wieners?
This call is recorded for corporate to review, so.
Okay, meters?
No, he meant we got hot dogs.
I don't think you're truly a tech yet. until
So
you
we're
got-
gonna go to our shop,
Look, motion
and I hope someone brought a meter.
I got a meter right here on the desk.
And I'll, take my laptop and the speaker.
Cool.
We'll go downstairs.
Let's go check what that's for, G. You know, I'm probably out there.
Yeah.
So I expect it's safe to say that most people didn't have a very accurate diagram, but you guys feel comfortable enough that you understand. If you're late to that, you know.
For the next hour, it's another chance.
Hey,
Oh, no, I drew it out. That's why I gave it an hour.
I heard the best thing is when you in the class, you retain 15% of what you know. You know.
That's what I do. So shit about America. Showed him 1776. That line he pluck.
Oh, yeah.
I don't know where you guys are set up at.
Kind of in the middle of that.
My video stopped working. Oh.
So do I look myself now or at least?
This is a little single. What's up, bro? You get real good stuff when you get on to a way 230.
No, it's all right. I think she said you said.
You know, the first time you know, something like Troy, it had nothing to do with it. I know the pros and cons.
One was good.
Separate.
Yeah. So what is it? Okay. Everyone in here? AJ, what's coming?
Okay. That's fucking
You want to be our meter person? You want to do that real quick? Okay. There's kind of just like the diagram you made up there, right? You still on video, Trav?
I was trying to. Might need to. Go grab that camera and I'll set it up here.
Turn up.
I like you finish.
Yes. Oh, it's a little.
Okay, so right now is our EVAP fan running? Absolutely, yeah. Is our compressor running? Yeah. We don't need to.
You need to hold that.
So first thing you can do is make sure your time clock has power. Like you check, turn off hot rate. And our neutral. So right now our timer motor is spinning, right? So this time clock, a little bit different than we do up there. We have two normally closed switches. One normally heavy switch, and you can see there's the. So you can see between the hot rate. And from the on it, put on the plug, and then they plug it. You know, hot rate and four is a normal plug three, normal goes low. And then between the hot rate and one. Was the normal way. In for grain, if that makes sense. Yeah, okay, so right now.
Can you guys hear us?
Terminal one.
Matt, can you hear us?
Yeah.
Cross switch is open. Then you have normal close right here and normally close right here. You can verify that they're both closed by going from on across. Well, those are both closed, so they should not be done, okay? Now is our solenoid energized. Our thermostat's closed, right? I don't know if you guys have ever seen this before, but when I first started my service manager, you know, you can do the magnet trick, right? You can see if it feels like it's magnetic. But if you switch your amp meter, if you switch your clamp to amps and just open it up and go right there near the coil, see how I'm seeing leading amps right now? So it's an easy way just to walk around and tell if your solenoid's in there. We got a little screwdriver. My hands are too shaky to want to stick my fingers in. What are you trying to do? Just open it. Okay, so now. Let's on the chat, see if it's open or closed.
Might need to talk a little louder.
Hey, you guys.
Travis,
John,
I got a question here.
Okay.
And then if you switch
All
back
right.
to amp,
When you are coming out of defrost and you got your 5-minute drip time, should the compressor be running during that drip time or should it be off?
Should be off.
Should be off. Yeah. It'll be flashing. If you got a
so if you do have a 5-minute drift time, you obviously don't want to energize your solenoid right away, right? If you energize your solenoid, you're gonna go up more pressure.
Yeah.
You will let
Well, that's the fan. That's not the dripper. That's the
No, I know.
So when we were talking earlier too about.
I was just looking at that.
We don't want our fan to turn on. Right now our fan's on, right? If you lower that down, we don't want our fan to come on until it's say 20 degrees in this freezer. You like come out of defrost and you walk in the freezer, you're like, what the heck, the fans aren't working. Is there one of these on it? Is there a click on it? Doesn't necessarily mean your fans are bad. It could be they're waiting till it's a certain temperature before it turns back on. So now our temperature dropped, getting colder. All need out fan turns on.
So in eastern Idaho, you guys have a electrical circuit that Matt made up, correct? So let's go ahead and try and do the same things at the same time. Well,
Switch is open or closed.
you know, just going through on off switches right now, your temperature, your fan delay. Just to kind of see what's happening, check your voltage across each one. Open or close.
Okay, so our compressor is running right now, right? So is our
If you
pressure
guys
switch
want to,
open or
Matt.
closed?
You're muted.
Okay, so our powerful meter.
He's gonna grab his meter, so.
Okay.
Oh. So is it open or closed? So now you can also go, you're doing upstairs, check your sliding ground.
Just put that. Yeah. He said, we real. Say them fake. That's open.
So that means that bottom terminal is your hot leg, right? This one. Yeah, what did you have on the top? 1.9. I like that ground wire in that bottom.
There you go, 120.
So our switch is closed, you have 0 across it, you have 120 to ground on both sides. So now, we're going along. About to go into defrost.
Oh, okay, I'm about to say.
So our evap fan turns off, right? Our defrost contactor pulled in. And then we have our defrost heater, right? You're sending power to your defrost heater. So in this scenario too, what would you have from this wire to this wire across the load of your contact? 120. It's 120 volt circuit, right?
That's the verified, yeah, we did.
But if you really wanted to, and you check from this blue wire to this side of your heater, what would you have?
Oh, yeah, nothing to the tone.
0. Even though it's not technically a control switch, right? It's still a switch. It's just sending power through. So in this scenario, between L1 on the top and L1 on the bottom, you'll have 0. You'll have 120 across your load.
Yeah. Okay.
So let's say this is our scenario right here. It's in defrost. Our heaters are running. Our evap fans turned off. But you're like, what the heck? I still hear the compressor. So you go up on the roof and our compressor is still running. What are let's just come up with 2 scenarios of why that compressor is still running right now, even though we're in defrost.
Repeat that first part again.
So we're in defrost, right? In theory, our compressor should be shutting off because it should trip on low pressure. Let's come up with 3 scenarios now of why that compressor is still running, even though this is in defrost. No fan switch for what?
No fan delay switch?
Oh, your fan's off.
It's still reading pressure. It hasn't pumped down.
Okay, so let's talk about Cody's scenario for a second. Obviously, this is just a trainer, right? There's not pipes hooked to everything. So if there's still pressure here and this isn't opening, what are 2 scenarios that would cause that? Well, it could still be pumping down. So let's say it's been pumping down for 10 minutes and that switch still hasn't. And not because I mean, it hasn't worked. Like, if the switch was bad, right, we would have in a vacuum right now, right?
Could be sure, their solenoid is bad.
Because if that's wired in series and that compressor is still running, that means that these.
So John says the solenoid. What if when your thermostat shuts off because you're in defrost, what if your solenoid never seats closed all the way and you're bleeding refrigerant?
You're never gonna shut the.
That's gonna be enough to keep your pressure switch closed, right? So that's one scenario. What's another scenario? Okay, you could have a bad pressure switch. If this is closed all the way and it's pumping down and your pressure switch is bad, what is your suction pressure right?
Negative.
In a vacuum, right? It should have shut off at 2 PSI or 5 PSI. So that's another scenario. Your pressure switch could be bad, right?
Or you can have welded contacts on your contactor.
You could have welded contacts, your contactor could be stuck together.
Definitely.
What if you had a bad compressor? Yeah.
I've actually had that happen.
What if your discharge valve is bleeding into the suction, keeping the pressure switch closed?
Ooh. Yep.
So just there, we listed 4 scenarios of why our compressor would still be running,
Is
even
that
though
when you
everything's
take-
pumping.
Is that when you do like your temperature? Your meter?
Well, if you gauge up
can-
to it with
you
these
can-
bad valves, you're
you
gonna
can
be
grab-
well above.
And your lines can see too.
Yeah, the person's probably sitting there doing.
If your gauges, if you're hooked on your gauges, you'll see your suction will be suction. So it'll be higher than what it should be.
Wacky inflatable.
Your discharge
It'll be hot, both sides.
Normally the discharge pressure is higher, right? And so
That's
a
what we
lot of
found
times, if
over
you
at,
try pumping it down,
Natural
you'll
Grocers.
see it hit 30 PSI,
But that's on
25 PSI, but it just
And that
won't
one,
keep
that one
going
blew,
down.
Hey, Matt,
Bad valves.
2 of the heads out and then busted 1 of the heads. It's completely out.
A way you could verify that if you do for sure have bad valves is usually your condensing unit, you have your.
is there any way we can, see your board and kind of what you guys are working with?
Your suction service. The reason why you still have pressure on your
Looking,
suction.
that was a freaking.
Can you show me your control board system, circuit system?
To eliminate this from the equation, you close the suction.
Can you pick up your laptop and show me it?
Still won't pump it, but it's gonna be a stomach of pressure into the suction. That's how you can eliminate it.
So what are you guys working on? Like, who's checking voltage and?
We're following what you were doing.
Oh, you said, I'm. No, this side.
Cool.
Same process. You essentially.
No one's checking voltage.
To ground.
Wait, no. Oh, okay. You can check it to a potato. What? Yeah.
Okay, so now it came out of defrost. Fan turned on right away. So we probably have a bad fan cycle switch.
Oh, the wind. Yeah, it's the wind.
Travis.
No, so disrespectful.
Travis, I gotta get going to Costco.
Okay.
So.
Oh, that's a compressor.
Tornadoes.
Well, Shank can keep working with the guys, right?
Supposed to be nice
Yeah.
and smooth.
I just gotta take my computer.
All right.
Now what are you saying,
So you guys can, log off if you need to, but, you know, if you guys want to spend some more time on it, go through it.
Supposed to be 3 pistons in
Okay.
there. Off inside.
Thank you.
Andrew asked questions, Anthony asked questions,
So dumping discharge gas straight in.
turn stuff off, pressure test it, don't pressure test it.
Okay. Yeah, I'll have one of the guys log in with their phone.
Cool.
Who wants to try to diagnose this right now? Who wants to try to diagnose this right now?
It's not hooked up. You gonna throw a problem to it?
Yeah, there is a problem out there right now.
Right here, right?
Yeah. So right now, you're in refrigeration, but your compressor is not running. What's wrong with it?
Are you maybe solenoid?
Okay, was your solenoid energized?
Do it, Wyatt.
Yeah, boy.
Yeah. Find out. Fine.
So Wyatt's looking at this wondering, how do I tell if it's energized? You can use the amp clamp, but when we were talking up there earlier, I was saying you don't have to always go across the exact same thing, right? You have this wire here going to your solenoid, right? This blue wire. And the other side of your solenoid comes back to here, which all of it comes back to your neutral here. So check from there to your neutral. So you're going across the load right now. Should your solenoid be energized in this scenario? Okay, so then you verify it by the amp. Okay, solenoid's energized.
How many amps did you have?
1.2. So we know our thermostat's closed. We know our solenoid's energized. We know our evap fan is running, which our evap fan is probably not running because our compressor's not running, so it's probably warm in there. We know our time clock's working because we're sending power to our thermostat, right? The solenoid's getting power.
Okay.
So what's next?
That's a fast train, but still.
Joel, you wanna get the meter going?
What else is your compressor running through?
And Bob,
What that?
we already verified that, right?
You got all the control, man. You got all the control of it.
So Joel says on the contactor.
Check your contactor coil first.
Coil.
Oh,
The back, yeah.
Don't ground out over there.
Come on, man, let's have a little bit
space
of
in there.
fun.
Zero, right?
I've got
So our coil's not energized. What sends power to our contactor coil?
Shut up.
What sends power to your contactor coil?
So because that's a
Shane,
low pressure switch.
Dylan? You're muted.
Am I unmuted? Yeah. What sends power to my contactor?
That's a dual pressure switch too, right? But really, in theory, it could be off on high or low pressure, right?
Yeah.
So hopefully your gauges are already on the circuit right now.
hooked up.
So you hooked up.
Andrew?
What's the pressure?
Hey, you gotta give me the scenario.
I'd say the pressure's
Don't do it.
Don't do it to me.
What
already
sends
open.
power to your contactor coil?
No, it's never gonna happen.
No, I already got that answer. So what was wrong?
No pressure,
So why isn't your compressor running?
because there's no refrigerant inside the compressor.
So it's off on what?
Lower.
Well, we know it's off on low right now, right?
No, it's on
So
fire.
your pressure control is open, right?
Shane, can you answer the question for me?
What's the question?
What's sending power to that contactor
Will you
coil?
grab one of those recovery bottles or something?
Wait, what?
What's sending power to your contactor coil?
Which one? The condenser?
Compressor contactor coil. Yeah.
Look at this.
Well, all the ones that I've seen, it takes a leg from the line and goes to the coil, and then the other leg runs through all of your safeties and then lands on the other side of your coil.
Which safety is holding the contactor coil?
Okay, so now,
Wait, how are we gonna demonstrate?
now
that?
just.
You got your low pressure switch, high pressure
Pull it
switch.
back in, change the dryer. Now he's charging it back up.
So your contactor coil, one side is directly to line, then the other leg goes through all your safeties and
So
then
you just
goes to
fix the
the
leak,
side of
you
your
pull it
coil.
back, charge it back up. Your pressure switch closes and now your compressor is running. Now your bath is dropping temperature. Your evap fan turns on. Freezer's fixed.
Let's get our
You
20%
can't get charged for charging a system. You can only get charged for venting a system.
There you go.
It's not vented. There's no.
Only if you get caught.
We do demonstration again.
I'll make a video real quick. $10.
TikTok.
Cause I split it with you on the end. It'll definitely
Get like
be
grand
Does
finder.
anyone have any questions
Yeah,
about some of this stuff?
out.
So that was.
Yeah. And you
Yeah,
lose.
Yeah, what
For
happens if
purposely
someone-
vent refrigerator.
and the high pressure, switches
Like a
fail?
water pump?
You want us to get approval, on site, do whatever we need to get that done without bypassing.
Just bypass
safety
it.
controls.
I wouldn't
I
bypass
don't
it.
want bypass nothing. I'll tell you right now, if we catch you bypassing safety.
I mean, if it's an accident.
Yes, sir.
Okay. If we had a guy that he bypassed safeties on a furnace and about burned a damn store down.
Yeah.
On the rooftop.
Yeah, don't do
They had
that.
to evacuate it freaking, I think it was a Trader Joe's. They had to evacuate the building because it's.
Well, think about this too, if you bypass the high pressure and you leave and your condenser fan fails and it runs really high pressure, instead of costing them that $60 pressure switch, now you're probably costing them a compressor and everything too.
Yeah.
No,
Don't
if you bypass your low pressure switch, now when it goes into defrost, it's never gonna pump down. So if you get busy the next day and the next day you get sick and the next day you gotta go to a concert or whatever, you come back, now you're gonna be de-icing that. The other side of it is too, you're gonna be running that compressor in a vacuum. So now if there's any leaks on it at all either, now you're pulling moisture in the system too. The pressures are there to like protect the compressor, so go get one, replace it.
Communication, just never, ever, ever bypass the safety. I don't care what the hell it is on. It's there for a reason.
But
You can do it for testing. But once you're done testing and determine what the problem is, you take that off and then shut it down.
now, John, are you saying you never arrived on the job site and you already seen the pressures bypassed already?
Yes, I have.
Yeah, okay.
Numerous times.
Numerous times.
Well, I can tell you this right now, when we took over Red Apple, almost all the freaking high safeties were freaking jumped out.
Oh,
Who wants to grab a couple of screwdrivers? We're gonna do one more fun thing and then call it a night.
I just did it.
Why isn't it running now?
That's a good fucking question.
Grab a meter.
Yeah, maybe.
I just did it.
Where's the meter?
Grabbed it.
Obviously, someone thinks you need that training.
Fuck, I guess.
So is anything running right now?
No, power's off.
So what's the very first part of the circuit? The switch is over here.
There's a light indicator. Look at it.
What's the very first component where the power is going to on the circuit?
Bad boy right here.
Do you have power going to the timer of your time clock?
Let me find out. Nothing.
Okay, so a fuse is blown, disconnects off.
Was that because it's closed or open?
You just check that right now. Is the time clock open or closed?
That's a good question.
Oh my God.
What's that?
Why it's gonna tell us the disconnect off, he's gonna tell us if our time clock is open or closed.
Close.
Nice. Not resistance, right? It's a low though, so
But the
it's not
best-
really open or closed.
But with that, if you're gonna test resistance, the best thing to do is take off all the wires so you're not back deep in everything else. So
Cool. Who wants to grab a couple screwdrivers really quick?
I will, Dustin.
I thought, who had their 11?
Yeah, who had that 11
I just
one?
a little tiny screwdriver. Matt's got one, but let's grab one more. So
Joel had
Yeah,
one.
have one.
I think Joel has one, maybe.
That's pretty good right there.
Okay, I want you guys to go through, I want you to take all the control wires off. You can leave the compressor hooked up. You can leave the defrost heaters hooked up. But everything going to your coil, your thermostat, your other thermostat, your pressure switch, and your time clock, pull the wires off.
Okay, Shane,
Yo,
I don't know if you heard Dustin, but we're taking off all your control wires from that board. So go get a couple screwdrivers and everybody pull off all the control wires from your board. So your thermostats, your coils, Pressure controls. Disconnect all the control wires.
Okay.
Have you guys do that.
Yeah.
Yeah, they had 4 other units. Good.
No, this only had the
Are you guys having fun?
Oh, this is great. I'll go home.
Full fun and adventure.
The whole day full of fun and adventure.
Yeah.
No, we're not.
No, it's kind of late on a Thursday already.
Sunlight everything.
What's this say?
You said control.
Everything off except for the compressors.
Who has another other one? I'm gonna start undoing these wires on this console. Hold on.
I mean, we got he got a schematic right there.
No, I said.
That's some probably really good wire, you know.
Make sure we get the lease rate.
Yay. Both are my hero jobs, sir.
Huh?
She's your hero. Huh?
What'd you say?
Oh, no, my wife texted me and asked me if my chauffeur, Mr. Dillon, would take me to Walmart tonight. Then she said we're her heroes.
Why does she need a headset so she can play your game with you?
No way, dude, that's my time.
That's a fact.
Okay, so pretty much everything's off, right? Okay, so you guys are gonna wire this back up.
Off that,
Stop circuit over there.
go ahead and take those off. We'll leave this one hooked up.
And we're gonna see if it works. Don't be afraid, guys. You got 5 hours and maybe a little more.
Wow, Cody, come on.
The only thing that this is all the wires stuck together, so
Everybody take turns.
pluck them all off and then put them all back on.
So Cody's gonna land one, and somebody else is gonna land something.
Yeah, they just yeah, that's a good idea. It's called Tech University, son.
Okay, after you get it unwired, Shane, we're wiring everything back up as a team.
Okay.
Just so he knows, Matt.
Oh, that's okay. We got a wiring diagram.
Not sure if they followed that.
Cody's cheating. He's wiring up the same ones he unplugged.
Okay. So where are we gonna start?
Cheating or am I just overachieving?
Overcheating, you ain't trying.
Our line one that's coming into.
Somebody let Gordon in there and wire something up.
Which wire is that?
And it's gotta meet electrical code 1613.
And that's odd, dude. Like all these.
They also don't have.
Should have used those Waco clips.
Double connectors, but like they protect your wires from the edges.
Oh.
Cheese nipple?
Cheese nipples or.
By the way, this is a race, so whoever finishes first gets a prize.
Oh, what?
Butthole connector.
Look at that detail.
And if you guys trip the breaker, you fail.
That means we get out of home. That's us. That's the end of the show.
I'm ready to go home. So I hope that if this breaks, now we gotta stay and fix it until it works.
Okay, so why don't, let's concentrate on the condenser side.
Shane, this is also a race, so it's whoever finishes first.
It's all right.
Oh, I don't know, dude, half of us were. Where's that screwdriver? Okay.
In my pocket. Gonna have to grab.
Boom, we're done. Yeah. Okay, so where are we getting our first contactor coil line of power from?
Where are we getting our first line of contact power from?
Yep. So we're gonna energize this contactor coil. Where are we getting our power from? Hold on.
Yeah, you can go, there's no, you need to go to handle it.
No, go from hot here.
Whammo, right there. And you
Why are we
probably
using
get that at Dollar Tree or Family Dollar on those coolers that you just showed me a picture of.
T-stack
Got
goes
that
for
little line pops over and goes from line straight to the coil, yeah?
I
So
have
that's
the
line
little
one.
jumper ring for the coil voltage.
And then, yep.
Yep.
And then where are we getting our line 2 from?
From your
I'm
pressure
kind
side.
of surprised nobody's gone and grabbed their wiring diagram.
What, we got one right there.
Where?
Right
here. Oh,
They're all home for
well, that's cheating too.
Okay, so we're taking line 2, running it. Switch.
Yes, sir.
And we're going to the other side of the
Coil voltage.
contactor. Oh.
Is that coil voltage 24 volt or 208?
Who asked that question?
Sir Dylan the Great.
120.
Okay.
Wait, press right?
Yeah.
Here, is there 24-volt coils in refrigeration?
Say what?
I'm not ignoring you.
24-volt coils in refrigeration.
I mean, if you have a transformer, maybe.
Okay, but we
No,
have a transformer.
not in this situation anymore.
When we're done, no one flip that switch on.
Wait, hold on.
Well, maybe got to be.
Is the power off or on?
It's either off or
Ours
trip
is
breaker.
Did anybody put a lockout tag out on the switch? No.
We
did.
Yeah.
There you go. That's what I got to take.
Yeah. We're still holding some wires over here, Wyatt.
Well, that's their side. I did my side. Look at that. Perfect. Damn, I can read.
Taco shop.
Yeah, this is the best. We're gonna run the bridge.
Here's the lockout tag out.
There you go.
Is that the phone?
No.
No, that didn't get the phone. Oh, that's no. Okay, so
I didn't look at it super thoroughly. No.
You didn't trust them?
I think you
That's a
got it.
bold move. The power switch over there.
look at that.
Okay, we have an evap fan on. Where's the meter? Is our solenoid energized?
Sounds like not that tight up, so.
Solenoid's energized. Pressure's in, our contactor's in. Switch there's closed.
Boom.
Check your voltage on the heater.
In the heater? Yeah, it's a heater. I think it's got over it. On the metal one? It's working. That's just that.
No, one time I thought it wasn't working, so I touched it longer. Oh, and it was working.
I will say,
Burn you too?
despite you guys having wires halfway where they go already, and the wiring diagram, and having to get to choose which wires are long and short, you guys did actually pretty good.
Thank you, sir.
Everything on it works.
Yes, oh, that.
Why didn't your compressor pump down during defrost?
Something's still energized. So
Pressure switch. Is it open or closed right now?
still running, but it's.
I'm gonna check and see.
Oh, so.
No, that's better.
Oh, it's 20.
Pump down now. Okay, so it pumped down, right? You think it's all good? While it pumped down, you like slipped in the snow and like shoved your hand against the condenser coil and you think, okay, it's a little damaged and bent, no big deal. I'm gonna turn it back on now. So now you turn it back on, your compressor won't turn on now.
Shoved your hand into the progressive pillow, but you think you'll have it good.
It'll be.
Well, your compressor switch still open or is it closed?
You guys know how, like, he just did it, but you can take a little service screwdriver and go underneath the bellows with a little pressure control and see if you can set it.
I will say that you guys did really good wiring.
No, that was.
Can't try it. I know how to read in a third grade level.
Anyone have any questions or feedback or comments or anything?
Listen, Gary, that's dope. I appreciate the hard work.
Very well, but it will work.
Where's that one?
Are you cool, Trigger? Yeah, it's a couple of coffee.
Push it down.
Oh, you gotta get. That's all right.
Do you have us some certificates from?
No, that's okay. I wish, but I'm not. Matt, you got any questions? I thought you might have some. What? On. That's these two cameras. While you go get your pressure control? Oh. Like it's already imploded. Yeah. I'll be right back.
I'm sorry this took up so much of your guys' time, but I hope this was like helpful. You guys learn a little bit.
This is awesome. What are we doing for the next thing?
I don't know. My voice has been gone the last 2 times we've done this. I think it's somebody else's turn.
You always come back from the concert, still talking just fine. Different scenario.
I kept my throat parched and nice and moist during the concert.
This is cool.
Cool.
Thank you guys for putting this together.
Yep.
I learned new stuff today.
The biggest thing I took from it is I didn't know that the timer off the defrost clock, it has that termination secondary to that click on. That's pretty cool.
Yeah. So you were asking earlier if a thermostat is a load or a switch. How fast the device versus something that freezes.
I will say, like, when I first started doing this, like the electrical, probably like the hardest thing for me. Trying to grasp line versus load. Should I read voltage? Should I not read voltage? And what really kind of made it click for me was someone pulled out a time clock, just like we did up there. Said you can see by these 2 wires, this is your load, hot, neutral. You can see where these 2 switches are closed, and these 2 are open. You can turn the clock and watch those 2 switches click. Then it actually, for some reason, like I can visualize it now. These 2 wires are powering the motor. When this is closed, it's sending power to there. When this is open, it's breaking power from it. That's really like what I was like a defining moment. I remember sitting there, someone showed me that. I was like, holy crap, I actually understand this.
I remember when we first did this in Baltic, like I had an understanding, but that wraps it in, but this definitely like.
Really, when you think other than like a supermarket with like a Dan Foss or something like that. I mean, a self-contained prep table, a two-door stand-up reach-in freezer, a walk-in cooler, a walk-in freezer. They might have slightly different things, but everything that we pretty much work on from a basic refrigeration standpoint is just like this. I mean, even an AC unit to an extent, maybe you don't have the time clock or the defrost heater, but you still have a thermostat, right?
You'll have your
We'll have a
high
solar
side.
You still have your high and low safeties.
Yeah.
Still have your compressor contactor, your fan contactor.
That's when you switch. So when now it's certificate, he taught me your high volt is dumb spot. And then you go after the transformer, you have smart power. And so in that instance, yeah, you basically only have a section of high power.
Oh, so proud of you.
So like when I diagnose, I just try to keep it simple because I can overcomplicate it myself.
It's real easy to do.
Yeah.
You have a lot of guys too, like it's frustrating, man. The diagram on the unit's half worn off or someone else is not knowing what they're doing and start jumping different wires together. Like me and Travis both said, if you get there and it's just a mess of wires, you don't know what's what, literally it's all just this. You can make any of that work by just knowing this. And then once all this is working, and then you know how to read your gauges and check pressures, and we already talked about superheat and subcooling. And we kind of covered the basic refrigerant cycle. Now we've kind of covered the basic electrical cycle. I mean, everything might have a little digital controller on it, right? But it's the same thing. You've got your power going to the controller, it lights up your display, it programs your settings. You have little relays in there that sends power out to this during defrost when it closes. When this one closes, it sends power to your thermostat to turn on your refrigeration circuit. Digital, this, even a Dan Foss and Albertsons. The only difference is stuff like this and stuff like this and stuff like that is being controlled by 4 points in a computer. Computer says, close my thermostat. Boom, it's warm. Two contacts. They close, refrigeration turns on. Computer says go into defrost. 2 contacts close. So in this scenario, our contacts are here, right? Defrost clock closes for defrost. Dan Foss tells 2 points to close, sends power to our defrost heaters. And really the concept's the same no matter what you're working on. It's just different means of doing the same things.
You were talking about earlier when you went out to replace a thermostat, or something. You might look at it, say, oh, well, this is what the wires were before. I'm gonna put it back this way. So why do they have it set up, between the fan delay and the PSAT on a different wire where it's landed? How come that one lands like that versus that one?
Because this one closes when the temperature drops to turn your fans on. And this one closes when your temperature increases to turn your refrigeration on.
So on the inside of your little electrical cover is gonna show you which one. Go.
And if your electrical cover is gone and they're not labeled, right?
We're trying to find the covers too.
Oh, turn this.
So you can
always talk.
You
can turn it off. Okay, so you don't have a cover.
Right.
This isn't labeled. You need to know what your refrigeration switch is, right?
And you don't have it memorized.
So it's right on there.
Your own meter, right?
Assuming there's no connections on it. We still have a
You trying to do?
Remember how to work my meter?
Touch these together, see if you can.
Shouldn't have to take that off. I just had to switch my mode on.
Oh,
You don't want to get any back.
there you go.
So right now, this is set at -20. Checking continuity.
What type of thermostat are you wanting to install? Closing on fall, on rise or closing on fall? For what, Mandalay? Just right here, so if
Just
you're
on this switch, this one, the
this
fan delay,
on
right?
that fan delay. You want it to close on rise or close on fall?
Who's on fault?
Cold that fall because you're waiting for the coil to not get cold enough.
That's
Yeah,
exactly.
blowing hot air.
So,
Yeah.
So
Closes
these
on
two.
So if I set this for 100 degrees, right? That's saying that my fan should be on anytime this is colder than 100 degrees, right?
It closes.
So right now, should our fans be on in this scenario?
This is, yeah, this is, yeah.
No, if you're setting this up for a fan delay.
So the way he's got this set up is a push. So this one's, it's gonna sense the cold. So once the coil gets cold enough and it says, fuck yeah, I'm good. Well, it's fire it down.
So here's a scenario, right?
I'm taking the thermostat.
This is a fan delay, okay?
You're thinking of
Yeah,
that.
yeah.
We'll do that one next, but this one's a fan delay right
I
here,
got you.
right?
I'm just.
We want our fans to be on when it drops in temperature. If we set this for 100 degrees, would our fans be on or off?
It'll be off.
Be off.
Yeah.
Okay,
I think they was talking about family. I was talking about the regular thermostat.
we have our thermostat set for 100 degrees.
Oh, because this is below your.
It's
temperature
below the temperature setting.
Yeah.
So if you wanted to run this thermostat for a fan delay, if you went over to this side, we're below 100 degrees, right? So our fans would be off. If we wanted to use it as a fan, our fan should be on. So if you are using this for a fan delay, you hook it up to these two wires because it's closed when you're below this set. The other side of it is let's say we want our box to be, so we want our box to be -20, -30, right?
Mhm.
We want our compressor to be on until it reaches that point, right? We obviously know we're not -20 right now, right? We're probably like 70 degrees. So if we wanted this to be our cooling thermostat, this should be closed right now, right? We go here to our common,
You're checking beep.
we're open here yet, we're checking for beep. So if we hook our solenoid up to this wire right here, and we want it to be -20 and it's 70 degrees in here, we're not gonna be energizing our solenoid. You go to this side. So you would hook our wire going to our solenoid up to this side. Does that make sense?
So now what are you gonna do? You bring in your new thermostat in, you swap it out, and you're gonna set your maximum or your minimum temperature differential range. How are you deciding when to do that?
After I just figure out which set of wires it's gonna go on for. Really, no matter what that's set for, if you max this out all the way, either way. If it's a fan delay, right now it's colder than 100 degrees. Whichever one of these is closed will be the fan. If it's a cooler, you set it to the lowest setting right now, it's warmer than that. Whichever one of these is closed now would be for your refrigeration.
Your schematic or your
All those
manual in the box?
colors should be gone, all those colors could be gone, all the numbers could be gone, the cover could be gone. But you can still determine which side of that you would use for either a fan delay.
Yeah. Whichever one's closed, like they say, like you maxed out, I think.
So when are you deciding to do, like, if you're gonna check things electrically, if you're gonna check continuity versus using the resistance, section with your electric meter?
I mean, me personally, if there's power already going to it, I like to check stuff while it's already hot, so I can tell for sure. I mean, there's no point, in my opinion, of turning it off without checking like voltages and stuff first.
That's the mistake I've
When you have stuff in series though, is when it's useful. You've got a high pressure switch and a low pressure switch. And your high pressure switch is open, maybe it's a bad high pressure switch. And then you run to the parts house, you come back, you put the high pressure switch in. All just to find out the low pressure switch is bad too. In that scenario, you check your voltage for your high pressure switch, okay, 120 across it, high pressure switch is open. Shut it off, you know what, I'm just gonna check the low too. So it goes beep, okay, my low pressure switch is closed, that's good.
Those pressures actually out of wet.
Really high resistance setting
I think it will,
on most meters,
I mean,
just goes up to a certain range.
Yeah, but what do you mean like high resistance?
Like if you have high resistance in something, it's not gonna show the continuity. on
Yeah,
it.
but I think almost everything on this control circuit,
Mhm.
you'd read something with your meter, open or close.
With the continuity setting.
So I hope that just kind of like helps you guys. You know, get a refresher course. I know the very first time I built this, before we made it bigger, like it was a refresher course. So you're sitting there, and even with me and John, right? Yeah, I was giving John a hard time and I was like, I'm like walking around, I'm like doing stuff, I'm like, John, like, what the heck is this? Like both these wires are on the coil. Because you
You had to
don't,
complete the circuit.
you don't usually have to just rebuild everything from scratch.
Yeah.
But you guys have the tools and the knowledge and the, you know, ability to draw your own wiring diagrams, and the ability to determine what to do if you did have to do
Mhm.
Awesome. Thank you.
And anytime you guys don't think around on things, go for it. We borrow that look like you could build like that.
Oh, that's bad. I broke it.
Do the flash on the first time.
it. Yeah, I've seen the new one.
Oh, I the new one up room.
The old one was just like on a smaller thing. all like turned together.
Yeah.
You just rebuild it off the clear. Just put like, put 2.0. Yeah.
Shane, how are you guys doing? You're muted.
Is this like
What?
Doing good? You doing good?
supposed to be used for only?
So we just showed on a contactor coil what it looks like when you lose a leg to your coil.
Well, things don't always have it. Little details off the thing, that table that most, they just turn on.
Yeah, you both seen.
Can you present that to me?
I said we just tested on our contactor coil what it looks like when you drop a leg out versus what it looks like when you've got both your legs to the contactor coil.
If you're working on
Oh,
a newer
okay.
unit though, like a deep track quick response controller, time where it will have an electronic.
Well,
expansion valve,
I think we're gonna be wrapping it up. How about you guys?
and it goes in a defrost, the electronic expansion valve is closed all the way, where a mechanical valve is constantly open.
Huh?
Yeah, so it's like you're such and stop and you're, looking like so much.
Me?
Wow, yeah, we took up a lot of time today.
Cool.
Yeah, you guys are always welcome just to stop by. If you see something, you're like, man, how did that work? Proud of him here, you know, I want to see this, or I misdiagnosed this, what could I do differently?
Compressor was starting backwards.
Yeah, Jack's never got this one, though.
No wonder this puppy was
screwed up.
And now we're doing that K too, like, and that runs, plus the defrost.
Yeah, and then
Like,
taking
for
care of
example,
it
that
for a while.
tobacco connection, we figured that defrost block is gonna
Ripped
be
open the
connected there.
stitches with the
So we're
scalpel.
gonna figure out a way to straight wire
Now,
bypass
I gotta deal
this,
with that.
and just so that K two.
Open the room.
So that's what we're doing.
Well, the nice part about that, the easy part about that is,
it's a 14-year-old black lab.
where's your solenoid at?
Oh, really? He looks better than he does.
So.
He's like, he was born in like December.
But the solenoid.
Hey, I forgot an electrical component. I think we all forgot it.
What?
What do you need?
We forgot the internal overload.
The way they're looking at it, you can all just get.
The
rid of it.
internal overload?
Yeah.
Yeah.
Bypass this.
Yeah.
Instead of having power here at your pump, you take those two wires, you power up your KD2 controller, then you have your wire for refrigeration going to your solenoid. Every wire.
Everybody
told me.
You don't need this at all. You
You
don't have to run any wires up the roof.
We tapped into that, like, we tapped to that light switch, so he's basically saying that we can just go the power to the defrost clock and just run that the power of the K two.
Did I make a mistake?
Go on with your bed, Phil.
Smarter, not harder.
I like it.
Hey, Travis, be careful, he's gonna pull your stuff.
Like, if we're out in the
The
field,
only thing that bothers me is you can go from like
you
sleeping
don't always have
like
a
crap.
diagram or schematic on there, like, we went over ladder diagrams today, but what happens if we get out
Yeah,
of
like
standard or pictorial or something?
Yeah.
Or what if
I think
somebody
really get around anymore.
doesn't have,
Yeah, yeah.
or the factory doesn't have like a start capacitor with the potential relay wires.
Okay.
I wish I had.
How do we know which one is, 2 to 5 you want? Do something like that.
Yeah, that would be cool.
Just wiring.
Austin's still on here. You got anything, Austin? You got any questions?
No, I'm just observing, just watching everything as it goes.
What do you think?
Sometimes they're difficult too.
I mean, it's very intuitive, that's for sure. I mean, it's nice to see how all these things are working together.
Yeah. Matt taking off?
So Christian said one of the things he likes to learn about too is like, different like wiring diagrams and like wiring.
Did Matt take off?
What
Tell him to step by.
are some other things you guys would like to go over?
How to make methamphetamine.
Motor loads,
Hey, we're not going over
Outside,
financial
fully.
freedom quite yet.
economizers.
Either way, I
I think would be a good one.
Okay, guys, we're logging off. Thank you.
Cool. Have fun.
Later, Dylan. Later, Shane.
See ya.
The more amps, the more heat.
Have a good night.
You as well.
Things connect. You've
Thank
got
you, guys.
line one.
Or the apprenticeship.
What's up, dude?
I'll leave the house.
I didn't hear that. No. Shane John felt that.
Does anybody know? Do I need to like?
Yeah. I'll stop.
Yeah, you could too, like Chris has been helping us out a lot. Everyone's kind of just. And then my friend's part of the car soon.